we will discuss about the standardization of HCl against sodium carbonate. So, standardization of HCl against sodium carbonate. But in this case, we will have one known solution. For example, we have HCl of known concentration. Then we can carry out the titration of HCl against sodium carbonate. We say sodium carbonate against HCl solution. So, and this one will be unknown. HCl will be known, and Na2CO3 will be unknown. So, if we come towards the reaction between sodium carbonate and HCl, we can say that in case of titration of sodium carbonate against HCl, you can say that first in this case you can say that sodium bicarbonate plus H2O. This will be produced. So when we want to titrate the sodium carbonate against HCl, when we add HCl into this sodium carbonate, we will get sodium bicarbonate at the first end point. First end point. This will be the first end point in which we will convert sodium carbonate into sodium carbonate, and this takes place at pH 8.3 by using a phenolphthalein indicator. Phenolphthalein indicator will be used to carry out the titration of sodium carbonate with HCl. In this case, sodium bicarbonate will be obtained. After completing the first, the color will be from pink to colorless. After completing the first endpoint, we will start to obtain the second endpoint by titration of this sodium carbonate with HCl, the same concentrations in the burette. So by adding HCl to this bicarbonate solutions, we will get carbonic acid. And this will occur at a pH around 3.8. The pH 3.8. This carbonic acid, we can say that sodium bicarbonate will be converted to carbonic acid by using an indicator which is methyl red. So methyl red indicator will be used transition range 3.8. This is the second point we obtain. So at this point we will heat up the solutions because the carbonic acid is formed required to be converted into CO2 and H2O, because some bicarbonate will also present in this case. So at this stage the solution will be heat up, and by heating this carbonic acid will be converted into CO2 and H2O. The solution is cooled down, and again titration will be continued by the addition of HCl, and the second endpoint at pH 3.8 will be obtained if we are performing potentiometrically. And if we are using indicator methyl red, then we will observe the endpoint of this methyl red to get the second endpoint. So the volume will be noted used of HCl. So, for example, here we will see example. We have 50 ml solution And these solutions contain sodium bicarbonate, sodium carbonate, and NaOH. We have 50 ml solutions containing sodium bicarbonate, sodium carbonate, and we're going to titrate it against HCl. Concentration point of 1 molar. We're going to titrate the solution of this with the HCl, which is of concentration 0.1 molar. So in this case, we will use two indicators, phenolphthalein. The first endpoint, we will use phenolphthalein indicator, and for the second endpoint, we'll use methyl red indicator. So we can say that we have we have we have for example, we have a beaker containing 50 ml of this sample. This is a 50 ml of sodium carbonate plus sodium bicarbonate plus NaOH, it may be. So if we're going to titrate, we have taken it in a beaker, is this one, and we are going to titrate this in a burette. It's a burette containing 0.1 molar HCl solution. So we will first use phenolphthalein indicator. Phenolphthalein indicator will be added into this few drops, and then we will start titrations of this sample with the 0.1 molar HCl. So in this 50 ml we add just 3 ml for DMW. It will be better. So titration will be started with a 0.1 molar HCl. So after adding the HCl, we will get to first EP. For example, we can say that 20 20.1 ml of 0.1 molar HCl is used to get the first end point. So in this case, titration will be stopped and the volume of HCl will be noted, which is 21.1 ml. Now, by the change of the indicator color, or by observing the pH at 8.3, or by changing the phenolphthalein color from pink to colorless, the volume of HCl will be noted. Now, the titration will be continued, and at this point, methyl, after obtaining the first endpoint, methyl red will be added to this solution, and titration will be continued again with 0.1 molar HCl. So when the methyl red color is changed, and we can say that the pH is reached to 3.8, here the titration will be stopped and the volume of HCl will be noted. For example, this is 48 ml. So this is the second endpoint at which total 48 ml of HCl is used, and this is the first endpoint where 20.1 ml of HCl is used. So we can say that we have noted that 22.1 ml of HCl is used in the first endpoint, and in the second endpoint, EP, say 48.4 ml of HCl is used. Now we will carry out the calculations procedure. You can say that we have in the first endpoint, so this 22.1 ml of HCl, this 0.1 0.1 millimole per ml. So this is this is 0.1 mole per liter. You can say this is a mole per liter or millimole per liter. It's the same case. So we can say that 20.1 ml into 0.1 millimole ml in this case will be cancelled and we will get millimole. So it will be equal to 2.21 millimole of HCl is you can say is used in the first endpoint. Now we will convert this into the concentration of sodium carbonate by doing this. You can say we have a sample taken which was of 50 ml. 50 ml sample was taken we previously discussed here. So 2 point we can say that 2 point so this one 2.21 millimole of HCl into divided by 50 ml. 50 ml samples. So we can say if we divide this 2.1 with 50, we will get point 0.0442 millimole per ml. We can say mole per millimole per ml. Millimole per ml. If we cancel the m and m, we will get also mole per liter. So this is equal to molarity. So we will get 0.0442 molar solution of let's say of concentration of sodium carbonate. This is the 0.0442 mole for sodium carbonate. We have obtained sodium carbonate. Now let's come towards the second endpoint, is 48.4 ml. So we will subtract this by 48.4 ml, which is used in the total titration, minus 22.1 ml, which is used in the first endpoint. So if we subtract this, we will get the net volume used for the titration of second endpoint. So if we from this, you can say we will get 20. The net will be 26.3 ml of ml for the titration of a second endpoint to be completed. So you can say for the first we have know that we have 22.1 ml of HCl is used, and for the second 26.3 ml of HCl is used. Now, this is the volume required for the titration of bicarbonate originally present, that's formed by the titration of CO3. So you can say this is originally present and that term carbonate which are obtained by the titration of carbonate. So this is the original form present, and this is the one which are obtained from the conversion of carbonate into bicarbonate. So we can say 26 will be converted. We have 26.3 ml of HCl into 0.1. We have millimole of HCl per ml is the concentration of HCl. So ml and ml will be cancelled, and we will get this millimole. So by multiplication of this figure 26.3 and 0.1, so we will get 2.63 millimole, and that will be equal to the bicarbonate. So this was the you can say that 2.63 millimole of so bicarbonate was that which was obtained from the conversion of Na2CO, you can say Na2CO3 to NaHCO3. This which was this one. Now we will obtained the bicarbonate present in the sample. So for this purpose, we will we obtained this one. This is a bicarbonate. Now we will subtract 2.63 minus 2.21. So this is the millimole of this, and this is the millimole which is previously obtained in the first point. So that will be 0.42 millimole. 0.42 millimole. So this will be converted 0.42 millimole, and the volume used sample was 50 ml. 50 ml, you can say 50 ml. So we have to be converted. This will be equal to 0.084 millimole per ml. Or if we cancel the m, this we will get mole per liter. We can say molar. So 0.084 molar of bicarbonate present in the 50 ml sample you taken is will be equal to 0.084 molar. So this is all about the titration of sodium carbonate, you can say, against HCl.